FP1 numerical methods, example 5. I'll do part A first. We've got a function here, sine x minus 0.4x, where x is measured in radians. Now, if you're not quite sure what radians are, if you haven't studied them in C2 yet, just set your calculator at the top where there is a letter D to represent degrees. If you find a button on your calculator that's labelled DRG, and move it into radians, so that at the top of your calculator in a little box there's a little R symbol. So try doing that now. All the things that we do in numerical methods, anytime there's a trig function, sine or cos or tan, you must be in radians, and the reason for that you'll study when you do C2. So we just do part A to start off with. Find the values of f of 2 and f of 2.5. Now you've set your calculator in radians, just substitute those in and see what you get, and we need to store the answers to these in our calculator. So for f of 2, hopefully you got 0.1092, and then for f of 2.5 you should have got minus 0.401. Now, remember what we did on the last example, example 4. This is below the axis. The negative shows it's below the axis, but when we look at similar triangles, we're only going to be interested in the length of the side. So if you save this as A, change that minus to a positive, because it's just the side length we're interested in, and save that as B. So it says, deduce the equation has a root. Well, we know that it is the sign change that indicates the root. And you must write that sentence. You get a mark for writing those words. Okay, let's have a look at part B. So linear interpolation twice. So we draw a little picture of our interval 2 and 2.5, and when we sub in 2 we get an answer that is positive, and we call that A, and when we subbed in 2.5 we got an answer that was negative. Make sure you take that minus sign off and draw in the line. So we're after this point X. So ratio of sides, this side here is 2.5 minus X, and this side here is X minus 2, and that's equal to, make sure you get them the same way around, this is B without the minus sign, and this is A. Now if we do the algebra, cross multiplying, we get A multiplied by 2.5 minus X is equal to B multiplied by X minus 2. So A times 2.5 minus A times X equals BX minus 2B. Again, get all the X's on one side. So AX plus BX at the right hand side, and then 2.5A plus 2B on the left. Factorise the right hand side, and then one final step to get X on its own, we would divide by A plus B, and you've got A and B stored in your calculator, so if you sub those in you should get hopefully that X is equal to 2.106, and that is roughly in between 2 and 2.5. It's roughly halfway, not quite. So that's the first iteration. We have to do it twice, so I'm going to start it off and then I'll let you finish this one. So remember, we've got to check whether this is positive or negative. So if you now work out f of this answer, let's call it C, and store it in our calculator. Work out f of C, pause the video and have a go. And you should get 0.0168. It's positive, which means we're going to replace this 2, which was our previous positive one, with this value. Okay, so C gave us a positive value. This is it. Let's call it D. And then 2.5 gave us a negative value down here, and we've got that stored. That was B, but we took the minus sign off it. Okay, you go through this same algebra again, pause the video and have a go. And if you go through all of that, hopefully, doing exactly the same steps as we did here, you get 2.1228 and so on. It hasn't given us a particular degree of accuracy that it wanted this to. So normally in an exam question it would, but given that it hasn't given us a degree of accuracy, we'll stick to the standard 3 significant figures. So we've done linear interpolation twice, and our improved estimate of the root is 2.12.